Let me ask you one weird question. How to eat an elephant? You may know the answer to this proverb. Cut it into pieces, and eat one bite at a time. We would apply the same rule to the big and complex project. If the project is complex, the project is formally divided into phases. For example, construction project can be divided into phases, called design, construction, and occupancy. Each phase contains logically related project activities. Therefore, phases are nothing but a logical division of project. The work being carried out within a phase has distinct focus from other phases. For example, design phase contains all the project activities needed for design and development. Construction phase contains actual construction activities to build the structure. Occupancy phase may contain all activities needed for commissioning of building systems and owner's possession. This division helps project managers and management the complex projects and have better control over the project deliverables. That is, eating an elephant, one bite at a time. Each phase has specific deliverables and objectives to be achieved. Design phase will deliver the schematic drawings, plans, bill of quantities, and other documents. Construction phase will deliver completed structure. Occupancy phase will deliver requisite clearances, commissioning reports, and other paperwork for possession. At the end of each phase, deliverables are transferred to the subsequent phase. For example, drawings, plans, and bill of quantities are handed over to the construction phase. Completed structure is transferred to the occupancy phase. Upon transferring the approved deliverables, the phase is formally ended. This formal closure of phase may be referred as stage gate, milestone, phase gate, or kill point. At this point, depending on the overall performance and circumstances, the project is reassessed for its continuation, or may get terminated. We have seen, each phase has distinct focus, specific phase deliverables, objective, and formal ending. Therefore, the complete set of project management process groups can be repeated for every phase within the project, starting from initiating, planning, executing, monitoring and controlling, and finally closing. The same 5 process groups can be repeated for construction phase and for occupancy phase. In spite of these project phase characteristics, please remember, project phases are elements of project life cycle. In fact, the project life cycle is defined as the series of phases that a project passes through. As we have seen, there is no standard or rule on how to set up project life cycle. The same applies to the project phases. For example, new product development project can be divided into phases called investigation, feasibility, design and development, verification and validation, product launch, and transfer to manufacturing. Hazardous facility cleaning project may be divided into phases called facility decommissioning, facility demolition, removal of waste, and landscaping. In short, projects can be flexible in terms of number of phases and their nomenclature. The phase structure is dependent on the unique aspects of its outcome, technology, organization, and preferences. There is no standard or rule for defining the project phases. On the other hand, the same standard set of project management process groups can be utilized regardless of type of projects. It is very important to note the difference between project phases and process groups. It is often tested in the exam. Project can be single-phase or multi-phase. If the project is small, project manager may prefer to run it as single-phase project. For such single-phase project, the standard process groups are executed at once for the entire project. In multi-phase project, the complete set of standard process groups are repeated in every phase within the project. The level of details and emphasis on each process group may vary for each phase in the project life cycle. Now, let us look at how project phases interact with each other within a project. The phase-to-phase relationship can be sequential. In a sequential relationship, only when a phase is ended, the next phase can be started. For example, once the complete design is frozen, and the design phase is ended, only then, the construction phase is started. In this approach, the risks and uncertainties are reduced, as the work is done sequentially. This also reduces the probability of rework, as the design phase and the construction phase are well aligned for the transfer. As phases are completed, one after the other, there are very limited options for speeding up the project. Phase-to-phase relationship can be overlapping. In overlapping relationship, as name suggests, phases can overlap on each other. For example, design phase and construction phase can run concurrently. In other words, even before the design phase is complete, the construction phase can be started. This approach increases the risks, because the construction phase is started without proper alignment, and much before the final design is available. Obviously, this may result in rework, as there might be mismatch between the final design deliverables at the end of design phase, and the construction done till that point. However, at the same time, there is opportunity to speed up the project, by performing the project activities concurrently. Project can have combination of sequential, overlapping, and parallel phase-to-phase relationships, depending on the risk appetite, and project schedule requirement.